Okay, functions. Here's the next set of notes for continuing our trig unit. This is the second part. I split this one up in two parts to make it shorter. We'll do the first part today, second part tomorrow. So if you printed out the notes, we're only going to talk about the first page. Okay. Date today's 3/19. Oops. All right, so in the first unit, first part of trig, we talked about radians, degrees, minutes, seconds, where the angles lie, all that. Now we're going to start talking, more specifically about circles. And today we're just going to do arc length. Okay. So arc length, I always consider it's like if the circle is a pizza, the arc length is the crust. Okay. So our arc length is, if you look at the picture, it's just this S. Okay. So that's your crust. That's what we're trying to find the measurement of. We're trying to find the measurement of the arc length. All right, so if you have a central angle theta, remember theta is always used for angles. So theta is this angle here. If you have a central angle theta with a radius of r, okay, again, radius is the distance from the center. So that's r, and this is also r. Okay. The edges of your pizza slice. All right, so you have the central angle theta and a given radius r, then the length of the intercepted arc, s, so the length of that crust, is given by the equation s equals, so the arc length equals, the radius times theta. Okay. So that's a pretty easy formula. If you want to find the arc length, you have to do the radius times the angle. Okay. Now the key to this is the stars here. Oops. Theta has to be in radians. Okay, if it's not in radians, we're going to have to convert that. Okay. All right. So it's just radius times angle. That's your arc length. So we'll just do the examples now. Find the length of the intercepted arc given the angle measure and the radius. Give your answer in terms of pi and round to the nearest tenth. Okay. Now generally, I don't make you do it in terms of pi. Okay. Because most of us are just going to type this into our calculator. And arc length is a distance, so it being in terms of pi doesn't really make sense. Like, no one really knows what 12 pi is, but you know what 39 is. Okay. So maybe I'll do one of each, but usually I'm perfectly fine just having rounded to the nearest tenth. Okay. So if you're using pi, you could use 3.14 for pi. Again, this is going to be done mostly in a calculator. All right. So this first one, we're given a radian measure of 5 pi over 6, and we're given an r value of 3. Okay. So again, if we want to find the arc length of those two measures, okay, 5 pi over 6 is, it's going to be roughly that angle. You have a radius of 3 and a radius of 3. So again, what we're trying to find the arc that connects those two, the crust of the pizza. All right, so we know the radius. We know it's 3. We know the theta. It's 5 pi over 6. So you just multiply those two together. Okay. So in this one, if I'm leaving pi alone, this would simply be 15 pi over 6 feet. Because the unit on that one was feet. Now again, I don't know what 15 pi over feet is. If that's a measurement, it's pretty meaningless to us. So again, if you want, you should convert this just into normal feet. So you can do 15 times 3.14 divided by 6. And you get a more meaningful answer of 7.9 feet. And that's it. The second one to the right of it, 2 pi is the measurement. Okay, now 2 pi should seem familiar. 2 pi is all the way around the circle. And you have a radius of 6.2. So really all this is we're trying to find the circumference. Okay. Circumference is pi times the diameter. But our arc length formula doesn't use diameter, we use radius. So that's where that 2 pi comes from. So it's going to be 6.2, which is the radius, times 2 pi, which is the angle. Okay. Now again, as with pi in it, that's 12.4 pi's. But again, I prefer, again, you could just do it. You don't have to even do this intermediate step. You could just do 6.2 times 2 times pi. And you get 38.9 yards. Okay. Again, that's it. Simple as just multiplying two numbers together. Now it does get a little different here when you're given an angle measure in degrees. Okay. If you're in degrees, we're just going to add something to the formula. Okay. Now your one option is you could just convert the 15 degrees to radians and then go through the formula. But you could also kind of cook it all into one. So if you're in degrees, the arc length formula is going to be the same thing. It's going to be r times theta. Oops. Times pi over 180. Okay. Times pi over 180 is what we use to convert degrees to radians. So we just add that to the end of the formula. It's automatically going to convert it to radians. Okay. All right, so let's plug those in. S equals the radius, 8.4, times theta, okay, which is 15 degrees right now, times pi, the whole thing over 180. Again, just type that all into the calculator all at once. 8.4 times 15 times 3.14 divided by 180. You don't need parentheses, you don't need anything. You should get 2.2 meters. Okay. Again, this is only if you're in degrees. Otherwise, it's just multiplying the two numbers if you're in radians. All right, and then this last one, it's in degrees again, 135. So you're going to take the radius times the degree measure times pi all over 180. And you should get 50, again, just all in the calculator, 58.9 kilometers. All right, then we got one word problem. Merry-go-round rotates 2,808 degrees per ride. How far would a rider seated at 8 feet from the center of the merry-go-round travel during the ride? Okay. So 8 feet from the center, well, anything from the center to the end of a circle is the radius. Okay. 2,808 degrees per ride. That's going to be the angle. That's your theta. Okay. Now 2,808 is way bigger than 360, but that should make sense because you're going around a circle multiple times on a merry-go-round. It's not just one circle per ride. That'd be a terrible merry-go-round. Okay. But that measure is in degrees, so we're going to have to use the conversion formula. All right, and just plug it in again. We're trying to find the distance traveled. It's going to be the total arc length of this circle that goes around multiple times. So start with the radius, 8, times the degrees, 2,808. And then since again it was in degrees, times pi over 180. Which means that rider on the merry-go-round went 392.1 feet. Okay. Now, if someone was seated closer to the center, they would travel a smaller distance. Again, we're going to talk about that in the third section of Trig. But they would go faster. All right, so that's it for now. We'll do the second page tomorrow. Hopefully that was a lot shorter than the first video. I'll probably post the homework up tonight, but it's not going to be due for, until after spring break. All right, have a great Thursday.